folks, was out on the bike the other day, bit of a disaster. On the way back, started misfiring at low revs, looked at the ammeter, full discharge, had the headlights, I was riding with the headlights on, turned the headlights off and it picked up, so I thought, ooh, something wrong with the charge in here, turned the lights off and made me way back home. Put the meter on, just on the battery with it ticking over, revved up the bike, no change. Normally you should see the voltage increasing slightly and obviously no movement on the ammeter. So I pulled off the wires off the two bullet connectors that go down into the alternator, the RM21, and I just put the meters on. I know it's not an accurate way to check or whatever, but between the two it was open circuit, so broken wire or something. So I'll pull the casing off. I'm just going to spin you around. So I'll pull the casing off, and as I drain the oil, this is the ATF. So it's a mixture of ATF and water. So obviously water's getting in somehow. How, I don't know. New gaskets and all that. Anyway, when I eventually pulled the casing off, the wire, this kind of, I don't know what you'd call this, this thing screws in to the inside of the timing case. Obviously the charging cables go through here, and it has this like grommet on it which grips on that and grips on the cable. Well, this has split and had dropped down, allowing the cable to move down. It had gone through that little, like a steel bracket, and the cable had eventually milled through, milled in half. So I've stripped it all out, I've repaired it, shrink wrap, amalgam and another layer of shrink wrap, obviously soldered, and I've got rid of this thing because I'm not impressed. Because the other thing that had happened, as this had come off, and I've been out in some really bad rain the last few days as well, water can pool, or water sits in that area behind the barrels, and it runs down there straight into that primary casing. So that's now redundant. And what I've done, I've found I had a few of these things, cable glands, not the right thread but the right size. So this out, now this goes in from the outside, it goes in and it picks up on the threads in the casing, and it's got a rubber gasket on there. Obviously the cable goes through and there's a rubber gland in there, so now not only does it grip the cable rigid to stop it moving down, I've now got a hermetically sealed cable joint as well, so no more water can get in and it's held rigid. So to prove there was good continuity, I didn't have any values, and I know you're only crudely measuring, like, you know, for continuity, because obviously, you know, the cable is a dead short. So I've got 0.4 of an ohm with the lead zeroed, so it's fairly accurate. And I looked at the one on my B25 and that was 0.42 or something, so no, the coils should be good. So I was just going to check the output. So I was looking in the book and it says you need a 100-watt resistor. I haven't got one. So, but what I have got is this twin filament incandescent bulb. So I was thinking earth and wind the two 35-watt connectors together, it's going to give me 70 watts, isn't it? So I'm going to hook this up directly onto the alternator. So if I wire this in series across and wire it in parallel across the windings, and then pick up with the voltmeter on AC across these two, this thing should light up and I should get a voltage reading, AC volts, and it says round about 8 to 10 volts or something. So I'm going to connect that up and give it a try. So let me get it connected up and then we'll see what's going on. So I'll see you in a short while. Okay, we set up, so I've got it hooked up with that bulb. I've wired both filaments together, so they're both 35 watt elements, so it should give me enough to load up or to put a load on it. And I've also got the multimeter connected to it in AC. So here's the there's the new, which I think is far superior than the other. So that's gland screws in, it's got a rubber gasket on the bottom, and obviously there's a rubber gland inside there, so there's no way that the cable can move now, slip down or anything, and there's no way any water can get in. So I've got the two connectors here going straight to the bulb. I've got the two filaments of the bulb wired together, so there, and that's the earth, and I've got the multimeter hooked in to AC volts. So let's just set you up and see if it'll give me some self fuel. Give it a quick tickle. Oh shit, I've got me flip-flops on. Don't matter, it should go, shouldn't it? Doesn't kick back, I hope. Okay, let's have a look. Oh, light already. I would say no problem there. That's really whacking some juice out that dynamo. So now I'm going to hook it all up and check it at the battery. See you in a sec. Okay, we're hooked up. Let's have a look. Nothing. Might have blown that up. I'll tell you what, let's check. We'll do a check on the wiring at the plug, because I can measure all four at the junction of this Lucas thing, Lucas version. So let me just set everything up. Be back in a second. Okay, there's the feed in from the alternator. Comes up to this, if you buy a Lucas one of these, comes up to this little plug. So if I unplug this, he said, then I've got my negative and positive, and I've got my two stator wires. So here's the meter, if it'll go in there. Oh yes, so if I set this to continuity and I go for the two yellows, which are the stator connectors, which is, I'll just do a, let's have a buzz. So I should get continuity. So there's one and there's the other, so that's 0.5, 0.6 or whatever, and I'm just going to check. I'll leave one in, make sure there's nothing to ground. Check the other one, no problem. And while it's on that, I can check the earth, go in the earth pin to the engine or whatever, and we've got a earth. So now if I go to 12 or go to DC volts, I've got my negative and positive, which should give me battery voltage, whether the ignition's on or not, because it's wired directly back to the battery, ignition on or off. It's always connected in the circuit to the battery. So I should get battery voltage here. And there's my battery voltage. So the we know the wiring's good. So now I'm going to take the unit off now, and let's do a diode test on the bench. But it's probably blown up, isn't it? It's got to be. So anyway, let's do it anyway while I got this far. So see you in a sec. Okay. So we're going to test. Took it off the bike, the regulator rectifier. A couple of ways to do it. We can either do it with a meter, or if you've not got a meter, with a diode function. You can also do it with a power supply. The good thing about the power supply is I've got that set to 12 volts, even though I've got the current set to maximum. It's got current overload protection, and it will actually just go off, switch off. So if you're going to use a battery or something like that, make sure you put an inline fuse in there if you're going to do it. Well, this is safe. So I've got neggy posi, and I've got my single phase rectifier I've just taken off the bike. So negative, positive, and these two are the signal or the sine wave voltage, the AC voltage from the alternator. So let's hook up. So I'm on. I've put positive. I'll tell you what, let's go positive onto positive. We've got to do them all anyway. Posi onto posi. Negative onto one side of my bulb. And we can go through the phases. So depending on which way, we don't know which way round these diodes are on the board in there, but here we go. So one phase, nothing. Other phase. Now this shouldn't light up. 1 second. It's a bit awkward with this fat pin. Okay, we're on it. Nothing. Nothing. That's a good sign. Nothing, nothing. So I'm going to swap the polarity over. Let's see what we get now. Yes and yes. So in that direction, those two diodes are good. So there's 4 in total, making the full wave rectifier. So now if I go onto the negative post and do the same again, yes and no. So I've got one on and one off. So depending which way round they are, they should either both be off or both be on. So let's swap the polarity over on these. On, on. So what it means is, if I swap them over now, back, they both should be off. And one is on. So that's on, which should be off, and that's off. So out of the 4 diodes, one of them on, and that should be off actually. Off, and that should be off. So one of the diodes in that board has has gone circuit right through, so either direction it's letting voltage pass in both directions. So unfortunately, when that unit, when I chopped through the wires with it milled its way through with the clutch basket sprocket, it's obviously gone to ground as well and taken one of those diodes out. So unfortunately that is scrap. So it's another 35 quid or whatever they were. I buy the genuine Lucas ones for this. Anything else I'll just put the Chinese ones on. But if we just want to prove this test, so this is what was fitted on the bike. Originally it would have had one of these, so let's do one of these first. This is a standard single phase motorcycle 12 volt rectifier. So there's 4 terminals on it. This bolts onto the frame, which is negative, but the top post, positive. It's a positive earth. They're all positive earth. It's a positive earth regulator. So that connects to that. So that's positive, that's negative, that's one phase, that's the other phase. So let's connect our positive onto here and our negative onto the bulb, and try the phases. On, 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 on. So if I swap these two over now, we should be off in both cases. Hooked up, should be off, 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 which proves that one pair of those diodes is good. We're now going to check the other pair. So we put this onto the top post. Now these should be on, 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 on. And when I swap the negative for the positive, they should be both off, 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 which proves that even though it looks a bit manky, that's a good it's a good rectifier. So that wasn't on the bike. I can't remember what that one was off. This is what was fitted to the Daytona. So this and the Zener diode, not this Zener diode, this is off a B25, I think this is off the B, but it's the same device. I've left it on the bike and the heat sink for authenticity, so it looks like it's got the conventional charging. So I've marked this up. These are cost buttons, a couple of quid, I don't know. So you've got a positive, and on the opposite corner a negative, and opposing them you've got the 2 sine wave signals. So we can check this as well. So we've got, I'll put our positive feed onto the positive connector. So the negative's on the bulb, and I can now go there and there on the sine wave and nothing. But if I swap the positive to negative over, they should light up, should pass through the diodes. On, 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 on. So now we take this off and we put it on the negative, and they both should be off. Off, 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 off. And if I swap the negative and positive over, they should now both be on. Okay, should be on. On, on. So that proves that that also is good. And a diode, you can check a diode. So they're negative ground, aren't they? You can check the Zener. Can't check to see what the spill voltage is. You can only check to make sure it's only working in one bias, one direction. So, sorry, lost you for a second then. So yeah, So if I put the negative onto the spade terminal and the positive through the bulb, there should be nothing, unless we were in an over voltage situation where it would be spilling to earth, which I can't prove, but there should be nothing, and there's not. But if we swap them over, we should see voltage and we should light up. So that's a very basic test for the Zener, but you're not measuring the spill voltage, like when they get to 14.5 volts or whatever it is, then it spills the voltage across the diode. It's called the Zener knee, and it generates heat, and the heat then is dissipated by the air passing through the heatsink. So you can also do the test with a multimeter. So let's get rid of this for a second. So it's just the simple diode test. So if we go for diode, which is second press on this one, and what it does, it now puts 3 volts through these leads. So in one direction, let's just do it on the where's the other lead come? Here we go. 1, 2. So if I just do it on a diode, one way, nothing. But if I turn the diode round, now the current's flowing through it, and that is actually, that half a volt is actually the forward bias voltage drop through this thing. So we can do the same with, let's just put a, so let's have a go on this. So posi negi, there's our phases. So that's forward bias through the diode. It's allowing voltage through, that's the voltage drop. Same with this one, it should be the same. And if we swap these over, there should be nothing. Open, open, and if we go onto the other, this time it's the negative, I should get pass through. Yeah, and this one also. Yeah, and when we swap them, there should be no pass through. Open and open. So that's how to use the meter. The other thing that I haven't done, just while I've got the stuff out, and I've got this is the bulb that I've still not fitted, which I am going to fit. The bulb I bought to replace the incandescent H4 bulb that I've got in the bike, which is 65 on main, 65 watt on main, and 55 watt on dip. So if I just, let's just see, make sure it's okay first, which I'm sure it is. So obviously these are polarized and they'll only work in one direction, hence me swapping, dead on 12 volts there, hence me swapping the, converting the bike to negative ground, plus obviously electrolysis as well, galvanic action. That's why all modern cars, bikes, boats, push, whatever, it's got a battery on it, they're all negative ground now. So this I know, because I know me wiring a bit. H4 bulb, that's the top, this left one's ground. So that would be dip and that would be main. Let's have a look. Wow, that's one bright bulb. Wow. Wow. That's a nice little bulb, that. I'm pleased with that. The only thing is now, what's it pulling? So what we can do is we can now just let me turn you off while I just set the meter up to measure DC amps. So I'll be back in a second. Okay, we set up. So I've got my 12 volts set, and I've got my meter now wired in series to measure DC volts, DC. So we should now see what it's pulling current wise. It's one bright bulb that. It's pulling 0.6 of an amp, and look at that, power to that for 0.6. That's on main beam. And just under 0.2 of an amp on dip. So that is one efficient, powerful bulb. Quite pleased with that. So we just work out if I've got it's a 65 watt on main, H4, and a 55 on dip. What does that give us in Ohm's law? Do it in your head, should be able to do it in your head. Okay, so the 65 watts, so 65 divided by the voltage of 12, so that H4 on main beam 65 watt bulb is pulling 5.4 amps. This one is pulling 0.6 of an amp. And what would the 55 be? Divided by, 55 divided by 12. And even on dip, which is the 55 watts, still pulling 4.5 amps. So well worth going for LED bulbs. You know, if you're struggling when you think that an RM21 can only deliver 10 amps, that'll be 10 amps in the upper 3,000, 4,000 RPM range. So if you're riding round with your lights on, and every time you press the foot brake 21 watt tail bulb comes on and all that, you know, you're skating on the edge. So that bulb is well worth it. The only downside is now got to buy another one of them. But I'm sure that's what it is. But anyway, we're done. 2-minute job to fit one of them, because obviously I'm going to buy the genuine Lucas ones with the plug, and it'll just plug straight in and bolt in. So there we go, folks. Hopefully no more traumas on the bike, and we'll catch you on the next one. See you soon.